This time around, I'm just going to go through all of the CAD functions, show you guys everything in the Create 2D tab, everything in the Create 3D tab, and then the utilities and everything else. And if you guys have any questions, please let me know. I'll answer any questions you guys may have. And if you don't, if you have any questions later on in the future, you can also call us or email us. Our tech support information here is, our phone number is 727-489-0003, and our email address is support@bobcad.com. All right, perfect. I've got the comment section pulled up, and looks like we're ready to go. So, up at the top, just as I mentioned, we're going to be going through the CAD functionality today. And in our previous video on CAD, we went through Create 2D design, creating a 3D model, working off of different UCS planes and things like that. So I definitely recommend, if you're interested in looking at all the CAD functionality, go back to that video to view how to work with the CAD functions. This one's going to be a basic functionality of every single CAD function here. So we're going to go to the top, and I'm going to start here with Create 2D. We've got points. So you can click on the icon for point, or you can click on the drop down here, and you have all of your different point functions here. You also have your point functions right here under creation option. That's what these options are right here under the drop down as well. So our first one that it brings up is just point. Sketching a point out here, I can click anywhere in the CAD workspace. I can modify it after the fact by typing in the coordinates here, let's say 3 by 3, right there for my point location, x3, y3. Some other ones in here, we have point from entities. So if I had a drawing, I can click on a line, and it'll create the points on each of the endpoint of a line, the center of an arc, an intersection of multiple lines and arcs, entity middle point, so the midpoint of the line or the endpoint of a line here. Next one is incremental. So from a point right here or from any other entity, I can type in, let's say, x1, y1. And when I hover over this point, you'll see it will create another point incrementally 1 inch over an x and 1 inch up in y. You can see the preview, and when I click on it, it will create that point right there. Next one is point on entity. So it's just like point incremental, but in a percentage. So I don't have like you could call it a vector. I don't have a line or an arc from this point. But say if I had a line here, not horizontal or perfect or anything, but that's okay. We go here to point incremental, and then we go over to point on entity. The percentage, 50%, will be from the endpoint over here on the left side of the line that I'm highlighting. You can see it's 50% over from that location. So if I type in 20%, it's going to be 20% over from the endpoint on the left that I'm hovering over now. Or if I hover over on the right side, it's going to be 20% from the endpoint on the right side there. Distance would be a specific distance here. So if I type in a 1/2 inch, it's going to be a 1/2 inch over from the endpoint here, or a 1/2 inch from the endpoint on this side. And angle would be for an arc. So if I had a circle out here, and I went to point on entity, and went to angle, you can see if I type in 0 for the angle, and I click on the circle, the 0 degree position is at the 3 o'clock position right here. So if I type in 90, it's going to go counterclockwise, and 90 will be at this location up here. All right, and then our last one here is point perpendicular. So if I clicked on a line, I think if I just click on these two, it'll create on lines intersecting each other, it will create anything that's perpendicular to each other. It'll create a point at anything perpendicular. All right, so that's sort of the basics with like all of the drop downs with point, and then you can see all of the drop downs with line, arc, spline, rectangle. So that's sort of what I was mentioning here was clicking on point. It will create it will start with the first creation option here of just point, sketch, enter. And then when I click on line, the first one will be line, sketch, enter. And then arc, same kind of thing, spline, rectangle. We have the main function here to start with when I click on the icon. And then I have the drop down here, which is just like clicking on any of the creation options in the line function itself as well. All right, so the first one is line, sketch, enter. So I can just click on a start point and click on an end point out here. Over on the left-hand side, I can also type in the start point and end point, or type in the length down here. And I can modify it after the fact before I hit OK or cancel. We have some other line functions. Line continuous would be, I can just keep on clicking start point, end point, which is essentially my start point for the next line, and then click on end point again there, so I can just continuously keep sketching my sketch here. Next one is line tangent. So if there were two arcs next to each other, I can click on two arcs and it will create a line tangent to the two locations there. We can see how that looks. Oops. We can see how that looks here. I've got two circles. I kind of like this one because in the line tangent, you can click on the top of the arc here and then the top of the arc here, and it will create a line tangent from top to top. Or if I hover over the arc a little bit closer from the top on this one and then the bottom on this one, it'll sketch a line closer to where my cursor is. So makes things pretty convenient there for the arc, for the line tangent. Line parallel would be if I had a line going out here and then I wanted to create a line of the same distance parallel upwards or downwards from this line. I can type the distance over on the left hand side, let's say a ½ inch. Click on the line, and then depending on where my cursor is, above or below the line here, I click on a second time to create that line a ½ inch above or below that line. And then the last one is line angle. Now this is sort of a tough one to explain here, but I'll do my best here. So angle of 45 degrees is just like creating a point at the 0 degree location would be your 3 o'clock position. So if I type in angle of 0 and length of 1 inch and angle of z-axis, I'm always going to keep at 0 because I'm sketching on this top plane, so I'm going to leave that at 0. And then these three options, angle option, are what we're going to go over. These are the most important things in here. So angle relative to entity would be the same thing as if I did angle absolute or angle tangent. Yeah. For this example, if I change it to, let's see, how do I explain this one? So let's go to angle of 90 degrees, and I'm hovering over the line on this one here, and then you can see that it is it's going 90 degrees from the 3 o'clock position counterclockwise, just like with our point. And so with this, it's going to be, I think it's a little better than doing a horizontal line. Let's make a line going about 45 degrees here to work off of. And then I'm going to go to line angle. The line angle, once you get the hang of it, it's going to be really useful because let's say it's 90 degrees, but I always want it to be going up 90 degrees. I could click on absolute right here. And so when I hover over this endpoint of the line, it's always going to be going upward at the 90-degree location in sort of a trigonometry sense of it, from the 0 degree being the 3 o'clock position. Or if I hover over the endpoint on the other side of the line, it's still going to be going up at that 90-degree position. Now, from absolute, I can change it angle relative to entity. Now, this one's a little bit different. When I hover over this endpoint, you can see it's not going upward, it's going perpendicular to this line because I have it at an angle of 90 degrees. And it's going to do the same thing on the other endpoint, but downward, because it's sweeping from this position, from the endpoint right here, and it's always sweeping counterclockwise. So that's why it's going downward on this one, and then it's going 90 degrees from that position, always sweeping counterclockwise. So that's why it's sort of, you could say, upward in this position. So those are the differences with your angle option, angle relative to entity, and angle absolute. Those are the ones that I most frequently use if I always want it to be 90 degrees upward in this position, midpoint, or the two endpoints. It could be 90 degrees, or any other angle that you need to always be at. Or if you need to go sweep from the line, let's say 45 degrees here, and then hover over the endpoint, you can see that it's going 45 degrees, angle relative to entity. It's almost at a 90-degree perpendicular there, up and down. What would that be? At 12 o'clock position. Or if I change it back to 90, you can see the difference there with angle relative to entity. Let's say I need to make a line at an angle that's, 10 degrees. From this line, angle relative to entity would be what you want to use so that you're just going 10 degrees from that location. All right, so we went through point, went through line. We can go through arc. Arc is really just sketching a circle. You can type in the start angle and end angle if you want to change the, if you don't want it to be a full circle, maybe a semicircle, you can type in 180 here rather than 360. And if you want the bottom half instead of the top half, you can just click on other half here. You can type in, I'm going to make a full circle here, and I'm going to type in where the center point is going to be here. I can type in the diameter of the circle. And you can also click on an endpoint of a line like this, and then click on the endpoint there to place it down exactly where you need it to be. Let's see, then you have other functions in the arc function. I normally don't use a lot of these, but we'll go through them. Arc 2 points. So instead of clicking on a point with typing in the diameter, you can click on a location out here, and then I can click on it a second time to place it down, and it gives me the diameter of where my cursor was the second time I clicked. And I can also modify the diameter over here after the fact. Then the arc 2 points for your diameter, you're clicking on one of the endpoints of the circle and then the other endpoint of the circle. I normally don't use those two, but I do use the other ones in here, like arc 3 points, center, and endpoints. Now you could click on, let's say, this endpoint right here as your center point, and then your first endpoint of the arc, and then your second endpoint of the arc. So sweeping around like that. I don't normally use that one. I normally use the next one over, which is arc, 3 points, endpoints, and radius. So first you're doing your 2 endpoints, and then the last one you're clicking on is your radius. So I'm going to click on these 2 endpoints of the line first for my arc, and then it's going to come out here for the radius option, and then I can click anywhere out here and then type in a specific radius that I want over in the left-hand side in the data entry window. Let's say I want it to be 2 inches for my radius, and then click OK. I use that one very frequently for arcs connecting, as you can see, from one endpoint to another, and then creating the radius that I want specifically. Then the other ones, arc 3 entities, tangent, tangent radius, and fit arcs. Those would be if you have existing geometry already and you want to, sort of like creating a fillet, but not trimming away the geometry that you have there. I see someone asking, can't see my cursor. I'm going to see if I can set it up this way to be able, I don't see anything that gives me the ability to highlight my cursor. But I'll do my best to explain things so that you can see where I'm going over to highlight here. So we went through points. You can see up at the top everything being highlighted: point, line, arc. We'll go to spline. I almost never use splines, especially for creating profiles for milling and things like that, because then it's just going to fit lines and arcs around the spline. But if you need to create a spline for whatever reason, you need to make some artistic work or anything like that to create, I'm going to create some points out here, just sketching a few points up at the top, and then go back into my spline function. And each of these different spline functions, spline type, they have different ways of interpolating the spline in between each of these points. So I'm just clicking on the points here. You can see with this one, it's spline approximated is making sure that the spline goes through each of the points. There's some of them like spline fit. We'll go in between them. You can see, so it's a lot different than the approximated. It just fits a spline in between each of the points there. Spline interpolated, spline blended. Spline interpolated looks like it's a much harder curve up here at the top for the interpolated, and then blended. See the difference between the two there. Not a huge difference. Oops. And you can see if I selected one wrong, I can hover over the point list over here in the data entry window, delete one out, and that way I can go back to selecting my geometry again there. Oh, it's really wanting me to click on that endpoint there. There we go. So you can see not a huge difference between some of the spline functions, but different ways of creating a spline in between points to get your specific spline that you need to create. Then we have rectangle. Rectangle is an easy one. You just hover over. You can type in where you want your base point to be here. You can type in your length and width of the rectangle. And let's say I want to create a sheet, let's say 96 by 48. I type that in here. And then I can click on this option here in the corner of the bottom left corner to be the corner of the sheet there. And then I can fill in all of my shapes that I want to cut out of the 4-foot by 8-foot sheet. So that's rectangle. First one there, rectangle center. Next one is rectangle 2 points. Just like with the arc, you can click on the center point and then click on a corner for your rectangle. You can click from corner to corner for your next one. Next one is creating 3 corners. So I'm clicking on one corner, clicking on like the length of it, and then clicking on the width of it after that for my 3 corners of the rectangle. Next one is rectangle 3 points, which would be the center first, then one corner, and then the bottom corner down here. That was a little rotated, but you get the idea of that one there. Let's see. After rectangle, then we have our shape library. So if I click on shape library, I can click on this icon disk. It will open up the library of all of our predetermined shapes. I could select one of them here. I could place it down out here inside of my sheet here and type in the parameters after the fact over here. So we have the dimension of 3 inches. So number 1 is our overall width here. Number 2 is our overall height. So when I start typing in the numbers, let's say 4 inches for the width, 4 inches for the height, it starts updating and then when I click OK, it will place it down where it needs to be there. And then I can hit cancel. So that's our shape library. It has a lot of really good shapes, useful shapes to have in here. Like up at the top, we have this slot, and then next to it, we also have this curved slot. So you can type in the width of the slot, the angle, and things like that. Some other ways to create predetermined shapes here in BobCAD. Over here, we have ellipse, we have spiral, we have gears. Under the drop-down, we have gear, sprocket, and roller cam. So as an example, I go here to gear. We can type in the number of teeth, the diameter of the gear, those kinds of options here to sketch a gear. If we're drilling many holes at a time, we can create a hole pattern or a point pattern. So under hole pattern, I can type in whether it's a circular pattern or whether it's a grid pattern. I can type in the number of holes in the X direction, number of holes in the Y direction. So let's say 4 in the X, 4 in the Y. And then the size of the pattern in width and height, and the diameter of each hole. We have our fillet and chamfer functions. So going along any corner, like let's say with one of these rectangles here, I'll go to fillet, and I can type in the radius. Or with chamfer, I can type in the angle and type in the distance of the chamfer here, and then I can click on the top line here, and then click on this line on the left here, and it will create a chamfer, 45-degree chamfer at a 1/4 inch there. What's next? So fillet, chamfer, 2D Boolean. I don't use this a whole lot, but if there are two shapes in here, so let's say like a rectangle and a circle that are intersecting with each other, 2D Boolean could be useful for two different shapes like this. The first one is 2D Boolean add. So it will, depending on my first geometry selection, like the square here, and then my second geometry selection would be my circle. You can see it will add everything, sort of like a Venn diagram, right? Everything on the outside will add together. Subtract would be, oops, let me get rid of the arc here, so that my arc is a second geometry group. So subtract would subtract the second geometry, so it would subtract the circle from the rectangle, and then intersect would be everything inside of like a Venn diagram, right? The overlapping part of it. Mike, good question. Can patterns be saved? Can patterns we create be saved to a library? No, we don't have a shape library where you can modify it or change the shapes in here. We're always going to have these specific shapes for the library. But let's say for whatever reason, maybe you like this shape right here and you want to save it as a template. What I normally do is I'll go to my select mode. I'll select it, and what I could do is, first of all, I could go here to the top, go to Home, and go to Copy. I'm going to go to a new file and paste it into this new file here. And I'm going to drag it down to translate it down here. Maybe further into the corner here, closer to my origin location. And what I could do is I could save this file. So I'm going to save this as test file in my downloads. And so when I go into a new file, or when I go into an existing file that I want to import this template into, then I can go to File, Merge, and then I can merge that test file into any new file or any existing file that I have. I can merge that test file into it, so I've got a template option like that. After the fact, once you've got your drawing like this, if you want to modify it, this is a good segue into Entity Modify. I can go to the top and go to Select Mode. Now I can double click on a line now. I'm going to double click on this top line. And now you can see over on the left hand side in the data entry window we have Modify Line. So the length is about 650, we'll say. We have the start point and the end point here. I can click on a point like this endpoint over here. I'm going to click on it, and I'm going to, let's say I want to make it more of like an angle like this, and click OK. Now it doesn't automatically update, but now I can double click on this vertical line here, and I can move the endpoint to snap right to this location and click OK. So I'd say BobCAD's not totally parametric necessarily, where you modify one line and everything modifies for you to keep the drawing as a closed chain. But now I think in the entity modify, it'll save you a lot of time to be able to double click on a line. You could move the line completely out if you wanted to, and then you could just go from endpoint to endpoint and go from point to point there to the specific location you need it to go to. And then click OK to modify the entity there. But yeah, good question. We don't necessarily have a shape library that we can modify in here, just modify the shape after we bring it in like this. But yes, if you want to make template files like I have with this one, I would just save it, and then I can merge it into a file, sort of like a template option like that. We could get into creating prints where we have template files for that as well. That's sort of at the end of the webinar here that we'll get into as well. But yeah, good question. Let me know if you guys have any other questions as we go through all of the CAD functionality here. Next, we left off with 2D Boolean with this shape. Next will be text. So I'm going to go here to text. I'm going to type in some text over here in the data entry window. I'm going to type in BobCAD. So you can see it down here at the bottom. I can change the height of it down here. I can make it 1/4 of an inch height. And over here in the font, we can change it from Windows fonts. So all of these fonts are what's on the computer. So if you go to an internet browser and you install a font onto your computer, it automatically loads into the Windows fonts here. But if you're trying to engrave this, it's not going to be very easy because you're going to engrave the inside of the B and the outside of the B. So instead of doing these sort of bubble letters in the Windows fonts, we can go over here to the BobCAD fonts up at the top of text. You have Windows and then you have BobCAD. So I click on BobCAD and you can see this text right here is what we call single line font. And then under the drop down, like the first 10 are really good fonts to be able to use. Let's see one a little bit more professional here. This AFNT4 is a decent one. I think number 3, number 2, those are decent ones for better options for fonts for engraving. And then I can click OK to place it down right there. Now let's say I want this BobCAD text to go along this curve of the geometry that I have here. That's under text, and that's under the drop-down. So text is the first one that we were just working on. The second one is fit text to a curve. First, I select the text that I created. I'm going to click on BobCAD. And then the next one is fit curve. So I'm going to select the curve, this arc right here. I can see the direction of it is going upward. That's because I clicked above the midpoint of the arc, above the midpoint of it. And then I'm going to go over here to my picking manager and click End Chain, because I don't need more of the chain all the way around. I just want this one arc to place the text on. And so I click End Chain. And then I can see the text is on the beginning of the curve. If I want it centered, I can click on, instead of Start down at the bottom of the data entry window here, I can click on Middle. It's going to center it there. Or End will be towards the end of the curve there. So middle would be centered. If I want to move it over a little bit more, I can type in distance from path. Let's type in 1/4 inch right here. It's going to move it over it's going to move it up 1/4 of an inch. And then move text from start, I'm going to move it 1/4 of an inch over. So if I want the text to be under the curve, since the height of the text is 1/4 of an inch, I can just move it down 1/4 of an inch here, and then it will be under the curve there, inside of my geometry. So, let's see, we got another question here. David asked, when modifying a line, what's the difference when clicking on the purple arrow versus the green arrow? Good question. That would be a good example for my angled line right here. So I'm going to go to my select mode, double click on the angled line. Now you can see the difference between the green and the purple. If I had a vertical, it's going to be pretty much the same thing, right? It's the red arrow is your X direction, so you can move it over in the X direction. Your green arrow is your Y direction, so you can move it up or down in the Y direction. And your purple is your tangent. So since I'm going into my angled line here, you can see that the green arrow, I can move it up or down like that. And then the purple will stay at that angled direction, just keep it extending it out with that same angle there. Good question with the entity modify. All right, I'm going to hit undo on that. And then we went into text. Our next one is offset. So let's say I need to do an offset of this geometry on the outside here, because I need to make the toolpath for whatever reason, or I need to make a boundary a little bit further out from this geometry. Whatever the reason is, you can click on all of the entities here, and then you can go over and click End Chain. And now you can see it's offsetting on the inside. It depends on the direction of the arrow, so it is going counterclockwise, and it's offsetting on the left for our direction. If I change that from left to right, it'll offset on the outside. I can change the distance. It is 1/4 of an inch right now. Let's say 1/8 of an inch. And every time I type in a number, and to update the preview here in orange, I can hit Tab on my keyboard, and it will update the number for my preview here as well. And then down at the bottom for options, we have sharp corner. So you can see instead of the arc around the offset, it will create a sharp corner for it here. And intersect all would be for any intersecting geometry. It will add the intersecting geometry for our offset as well. And I click OK. Let's see, next we have extract edges. And all of the other ones are utilities for creating wireframe from surfaces and 3D geometry. So I'm going to go over to my cube that I have here. I just went to create 3D, and I went to cube, and I made a 2 by 2 by 2 cube here, and clicked OK. I can go to create 2D. I can extract the edges from a surface or from the whole solid here. Now I normally do that by creating wireframe on a different layer so that I can see it in relation to the solid. So over here on the right hand side, you can see down at the bottom right, you can see my layers tab that I just opened. This solid is on the CAD layer that the file starts out with. And then I right click and I go to add new layer here in the layers page. Now I can type in whatever I want here. I'm going to type in wireframe. And then when I go to extract edges, I can click on the top surface here and click OK. And then when I hide the layer that the CAD layer that the solid is on, the CAD layer here, I just click on this hide button with the eyeball icon to blank that out. And then I've got the wireframe of the top surface that I clicked on and clicked OK to make that wireframe in my extract edges function. Now you can see in the drop down there's extract edges, that we just went through, and also extract edges from solid. Basically all that does is it checks the box here, pick whole solid over here in my data entry window. And then when I highlight the solid, it's just going to highlight the whole solid for me. So then when I click OK, it creates the wireframe of the whole cube. So these are all lines now that I can modify, use as a boundary or whatever I want to use that wireframe for. I'm going to hit undo a couple times, and we'll go back to the extract edges function. And when I click on this top surface again, I'm going to actually project it to a Z-plane. So over here in the data entry window, you can see the checkbox at the bottom is project to Z-plane. When I check that box, it asks me what Z height I want this geometry to flatten down to, or flatten up to. So if I had, maybe an angled surface and I wanted to flatten it, it's going to compress, just to let you know, but it's going to flatten down to, we're going to say Z0. So when I click OK, that wireframe is going to be in the center of the cube because it's going to flatten down to Z0 there. Or it's going to project down to Z0, I should say. All right, cool. Let me know if you guys have any questions with the extract edges there. We'll go through the other ones here. Let's say we'll go into a new file now. And I'm going to do, I'm going to go to a new file. And I'm going to go to Create 2D. I'm going to go to Shape Library and go to the star. So I've got a star right in the center here. I'm going to go to Create 3D, and I'm going to make a sphere right in the center here as well. I'm going to make the diameter a little bit larger than the star, and I'm also going to place it on a new layer. So the sphere is going to be a diameter of 4 inches, and it's going to be on a new layer separate from my star here on this sphere layer. So I can see the star inside of it. And then I'm going to go to Create 2D, and I'm going to project that 2D star onto the spherical surface. And that's under Create 2D, and that's under Project Curves, which is right next to Extract Edges. So first I select my curves to project. That's what this window is for here. And then I highlight this next selection, Select Surface, or Select Solid. And I'm selecting this sphere, and then I click OK. Now you can see the wireframe, the star is on top of the sphere. It's also going to be on the bottom of the sphere. So if you have, it sort of projects along Z in positive and negative, just to let you know. So if you needed to delete the bottom wireframe for whatever reason, you don't want that anymore, you can just hide the sphere layer. You can go to your select mode and delete that bottom wireframe if you wanted to, by just window selecting it like this and hitting delete on your keyboard. And then you've got the wireframe on top for your, if you want to do like a 3D engraving or something like that of the star shape here on your sphere. So we went through Project Curves. Section View is sort of like if we want to create a print and we can get the section view of the sphere. I'm going to put that on a new layer here and click OK. Oops. Let's go to Section View, select Solids, and confirm. And then we click Create Wireframe down at the bottom here. It creates the wireframe of the sphere. So it will create a cross-section view. If you've got a 3D model with holes in it and things like that, the section view can be really helpful to create a print for that. Spun profile. This would be if we had a cylindrical shape, we can get the wireframe of the cylindrical shape for the wireframe for turning. Unwrap would be if we had cylindrical geometry and we create a flat surface for it. And these are some of some of like the miscellaneous functions over here in the utilities that I don't frequently use, but we could go through them, just talk about them real quickly. Contour would be if we created, now contour was in the older versions, if some of the OG BobCAD users in the chat know, like version 19 or version 20 or 21, the contour was used to define the direction of a profile cut. Contour is not necessary anymore, but if you still use that old school way of creating the contour, creating the direction of your profile cut in milling, that's that option here. Continuous sketch is just like in the line continuous. Exact iso curve and silhouette. Now exact iso curve would be if you wanted to create wireframe, like from this surface here. I click on the surface, it'll go all the way around. For a cube, it'll just go back and forth, but for this one you can see the U position and the V position as well. It'll give you sort of like the cross section of where my cursor is located. So you can see that intersection right there, that's where my cursor is showing. I can move it around to get wireframe. Oh, it didn't create it. Exact iso curve. I think I have to click on it, and then I click OK over here to create that wireframe, like that. So more wireframe options to create your iso curve, and silhouette is another option for creating a section view. It could also be used with creating a section view from an STL file. Doesn't always work exactly how I plan it with the mesh-based files, but I've been able to get wireframe from STL files with the silhouette function. That can be useful there. All right, we've gone through all of the create 2D functions. Please let me know if you guys have any questions with creating 2D wireframe, and we'll get into the 3D options. I'm going to go to a new file, and under create 3D, the first 5 here are our primitive functions, primitive 3D models, a basic cube, a basic cylinder, where I can type in the diameter over here in the data entry window and the height of the cylinder. I could also click on one of these arrows and drag it out further, drag out the height there, and click a second time to change the height. We have sphere, where you can type in the diameter of the sphere, cone, where you can type in the height and the top radius and bottom radius of a cone, and torus to create this donut shape. All right, and then next will be extrude boss and extrude cut. These are the ones that I most frequently use in the create 3D. So I'm going to create a rectangle, and I'm going to create a circle out here, and they're going to be intersecting for a reason that I'll explain later. All right, so I'm going to look at it from a top view. Here's my rectangle, and here's my circle. And then I go to create 3D, and I go to extrude boss. I'm going to do an extrude boss of this square to make it a block, and I can type in the distance over here in my extrude boss function. Let's say 2 inches up. I hit tab to update the preview. In draft angle, I'm going to type in, just to see as a preview, I'm going to type in draft angle of 10 for 10-degree tapered walls on the sides here. But I'm going to zero that back out, so I've got a rectangular shape there. And then I'll click OK. Now I can go to extrude cut, and I can cut that little corner out from the block by clicking on the circle here and making sure I'm going at least 2 inches up so that I'm past the block. I went 2.5 inches, so I'm cutting away from it, and anything past that I can cut away from as well with that distance of the extrude cut. Now next, let's do extrude boss. So extrude cut cuts away from the block. Extrude boss adds to the rectangular shape there. So you can see when I go into my select mode, I've got one solid. Now let's say I'm trying to make an assembly, and I don't want to... Yep, you're already ahead of me there, David. Question was, when would you use extrude boss versus extrude curve? So you can see I did 2 extrude bosses. It's one solid. Now say, as an example, I want these to be two separate solids to make an assembly. That's where your extrude curve would come into play. So I'm going to go to extrude curve, and when I'm doing the extrude curve here, I'm going to go up 2 inches again and click OK. You'll see that it keeps the two solids separated from each other. So now I can go to my translate and translate this cylindrical shape over. Let's say, for whatever like the block is maybe part of a vise and it's holding on to that cylindrical shape. Now in the extrude curve, it keeps them separate. If you wanted to add them together automatically, the extrude boss would be your function you want to use. If you want to keep them separate, extrude curve is what you would want to use. Next one, extrude surface. I almost never use this one, but let's say you've got a surface like this flat surface right here of the cylindrical shape. We go to extrude surface, and you could extrude it into a solid with your extrude surface function. And it looks like the extrude surface also keeps them separate. Extrude boss just sort of saves you an extra step with the extrude curve, because when you go into extrude curve and they're separate, and maybe after the fact you're like, oh shoot, now I want them to be added together, then you could go to your Boolean, your 3D Boolean option here. Your Boolean add would add the two solids together. So it's sort of like if you just did extrude boss, you'd save a step without having to do extrude curve and then Boolean add. But if you wanted to do it after the fact, you could add it together. I'm going to hit undo, and then we're going to go to subtract. So I could subtract this corner from the cylinder by selecting this as my main solid, and then the rectangular block as my surface or solid that I want to subtract from. Got that little corner out of the cylinder. And then the next option down is intersect. It will keep that little corner area. It'll keep whatever's intersecting there, whatever's overlapping. So that's your Boolean function there in Create 3D. Now, what's next? We could do imprint. I skipped over that. Imprint is a really good way to create a really good way to create shapes for molds and things like that. I'm going to go to, let's see, I'm going to go to a new file. Go to a new file. I'm going to go to create 2D, and I'm going to go to gear. And I'm just going to do the basic gear shape here and click OK. I'm going to go to create 3D and go to extrude boss and extrude this out, let's say 1 inch. And let's say I want to make an imprint of it halfway down into the model there. And so I go to create 2D, and I have to make the rectangular shape or whatever shape outside of my my mold shape. So I'm going to go to rectangle, and let's make this rectangle 12 by 12. And what I'm going to do here is I'm actually going to drop this rectangle down a certain amount in Z. So I'm going to drop it down 1 inch. So you can see in rectangle, I have length of 12 inches, width of 12 inches, x0, y0, but my base point in Z is -1. And then I'm going to click OK. So that's the stock shape, my profile of the rectangle, and then I'm going to make a print from my gear shape here. I think they call it electrodes with wire EDM. You could make for this. It can be really useful. So we go to create 3D, and we go to imprint. So first option here in imprint is profile chains. I'm going to select the rectangle. Next option down is select solids, so I'm going to select the solid. And then the next option is distance. So when I look at it from a side view, this is why I drop the rectangular shape down 1 inch below the gear, because we're starting from the rectangle and working our way up, I'm only going to go up 1 inch plus a half. So the distance here, I'm going to type in 1.5 inches so that I'm halfway into the gear shape. And then I'm also going to put it on a different layer. So before I click OK, I'm going to add a new layer, and then I'll click OK. So that imprint is on the layer that was active with the green check mark. So when I hide the CAD layer with the gear on it, now we can see the imprint. So if you've got a cool 3D model shape, and you want to make the mold of it, you can do that in the imprint function. All right, we're about halfway through the 3D modeling options here. Please let me know if you guys have any questions with Create 3D now. Advanced holes would be if we had any holes in here, I can tell the software any thread types, counterbore, chamfer options. So that way when we get into 3-axis milling or a new milling job, I can just reference this advanced hole option, so it'll pick up all of the geometry for me and compute the toolpath for the chamfer, the counterbore, and the thread option in here. Next, we'll get into the surfacing options. So I'm going to go to a new file. Let's just do a basic square here in the center, 2 by 2. We go to Create 3D, and our first one is planar. Planar is just creating a flat surface from any 2D wireframe like this flat shape here. I select the rectangle and click OK, and it creates a planar surface across the rectangle. Now let's see, the next one would be revolve. So let's make a profile for a turned part or a cylindrical shape here. I'm going to go to Create 2D, and let's make a couple lines here. I'm going to make a line, let's say, going out here. Click OK so that I can go from this endpoint and go up. Click OK, and then from that endpoint, I'm going to go out. All right, 3 lines here. Then we go to Create 3D. We go to Revolve. I'm going to simply window select the whole profile there and click End Chain over on the right-hand side in my picking manager. And so when I revolve this around, I'm revolving it, or yeah, I'm revolving the view here with my mouse. I'm clicking and holding the scroll wheel and moving my cursor over to see exactly what I'm looking at on an angle there. So it's half of the shape over here in the data entry window, rotation angle of 180 degrees. I'm going to change that to 360 to create a fully cylindrical shape there. And I'm looking at it on a top view. I can easily go from any kind of isometric view like this to a top view by clicking on this top view icon right at the top here. If I zoom in too far and I can't find my 3D model anymore, then next to the top view, up at the top here, over we have Zoom Previous, and then over I usually use this Fit All option, this magnifying glass with a capital A, and it fits everything back onto my screen for me. All right, so we will cancel out of that. That was our revolve function, and then we're getting into some of the less known and the less used functions, but they could be useful here. If I go in, let's say I make a profile first. And then I make a fillet on this corner. Let's do a 1/2 inch fillet so that we can follow along this path. And then I'm going to make a circle with a 1/4 inch diameter. So these shapes can be anywhere in your CAD window. And then you can go to Create 3D and go to Sweep. Now you can see the example it gives you here of number 1 and number 2. So first, before even going into number 1, we have our attachment point. So the attachment point is where it's going to attach onto the path, this circular shape. So I'm going to hover over the circle, and I'm going to click on the center point of the arc here for my attachment point. My sweep profile, I'm going to select, looks like I'm selecting the circle. You can see the example here of number 1 is the circle. So I'm going to click on the circle, and then I'm going to click End Chain. And then I'm going to zoom out. For my number 2 selection is the sweep path. And so I'm just going to window select my path here, and then click End Chain. And then here is our sort of like a pipe shape with a 90-degree elbow right there. And that's how you can create a shape like that. So you're sweeping a surface along a path that you've created with a closed chain, basically. I think, maybe let's do a square, right? I'm sure we could do a square here as well. Let's say 1/4 inch length, 1/4 inch width. And I'm going to put that square where the circle was. So first we go to create 3D. We go to sweep. First my attachment point. Now since I don't have the center point of the circle, I'm going to click on one of the corners. Now this corner that I click on right here is going to connect to the path right here. That's what that attachment point is pointing to. So I click on my attachment point. I'm going to window select the square for my profile, and then I'm going to look in a top view and window select my path and click End Chain there as well, and then click OK. And then there is our square tubing right there. So the surface sweep function can be really useful if we're trying to create this kind of geometry, either like a cylindrical shape or even a square piece of tubing like this, and sweep the path around like this. Alright, next we're getting into cross-section. Now I almost never use this one, but it could be useful, I guess. I could show you an example of where this could be useful. Now to make a basic shape like this, I'm just going to go to create 2D, and I'm going to go to spline. I don't have any points to click on, but I'm just clicking on points that I want the spline to go through. Let's do this and click OK. So I've got what, 1, 2, 3, 4, 5, 6 points to make this spline. And I'm going to actually make another spline as well, sort of in between here. I'm just going to do it the opposite way. Sort of like this weird DNA strand here. Okay, cool. So, with one of them, I'm going to move it up in Z. So I'm going to go to the top, and I'm going to go to Utilities. I'm going to go to Translate. I know we haven't gone through the utilities yet, but I'm going to explain more about these later after we're done with the Create 3D. So I'm going to move one of the DNA strands, if you will. I'm going to move one of the splines up in Z. I'm going to move it up 1 inch. And click OK. And then I'm going to move both of these. Let's see, we're going to move them 2 inches up. And I'm going to make, let's say, 4 copies. So how many splines do we have in here now? We've got, what, like 10 of these, because we've got the 2 originals and 4 copies of each one. So we've got 10 splines that are crisscrossing each other in here. I'm going to go to Create 3D, and we're going to cross-section. Now the cross-section surface function will create a surface in between each of these splines. So I'm going to select the bottom spline first and click End Chain. Next I'm going to click on the next spline up and click End Chain. Now you can see the surface starting to form in between the 2 chains. Next I'm going to select my 3rd chain over here and then hit End Chain. and then keep going and keep going and keep going. Now these are really close to each other, so I'm gonna maybe skip a couple here and make it like this and click OK. So here's our surface. You can see all the peaks and valleys that it creates in between all of the splines that I've selected. The only real world function I've come up with so far was like getting into BobCAD and VCarve and things like that. I had a customer who was cutting out an American flag out of a piece of wood, and he wanted it to have this wavy type of, he wanted the flag to look like it was waving. So we were able to create a cross section surface like this, and then create the stars and stripes along it to be able to create that look for him to be able to carve that out. There may be other uses for cross-section. I haven't really come across them, but let me know if you've used cross-section for anything else other than what I mentioned. Being able to make something like this for a wavy type of shape there for a flag to make it look like it's waving or things like that maybe. All right, go into a new file here. Went in cross section. 3 curves would be if I had 3 entities like this here. I'm just gonna make a triangle shape. Now this is a flat shape, but let's say if any of these were pronounced in 3D, and we went to create 3D, and we went to 3 edges, I could select the first one, click end chain, click the second line, click end chain, then click the third line and click end chain. It will create a flat surface here for the flat wireframe that I have. But you can see here in the example, if I had any 3D wireframe, a curved wireframe like this, it will create a curved surface from the 3 edges I select. And same kind of thing for the 4 edges. So let's get into a little bit more of the 3D functionality. If I have, I go into rectangle. I've got a basic rectangle shape here, and I'm going to make these into arcs. So we've got more of like a curved surface like this here. So I go into arc. I'm going to go to my arc 3 points, endpoints, and radius. I'm going from endpoint to endpoint here, and creating an arc like this, and creating an arc over on the other side. Let's make it a little bit different than the other one here. Make it a little smaller there. Cool. Okay, perfect. So you can see I went into my UCS page over here on the right hand side. We have our layers, posting, and UCS. UCS stands for User Coordinate System. I went on a side UCS, or on a side plane, to create geometry, to create an arc that's protruding up from the top view here. Now I'm not getting into the user coordinate system today, but as I mentioned before, if you want to see how I create a 2D shape on a top plane like we have here, then creating a sketch on a side plane, and then on the front plane, and creating 3D geometry on those different planes, I very much recommend going back to our CAD webinar that we did. It's the 9th one down in the list of webinars on this live events page. It's a great one to go over to review after this one, to be able to create 3D geometry on a different UCS. I went into a lot of that so that you guys could follow along. So we go here to create 3D. We go to 4 edges. So here's our geometry selection for 4 edges. We're just going around just like you can see in the example. So I'm selecting this straight line first and clicking end chain. I'm clicking on this arc here that's connected to it and clicking end chain. And you can see the direction of the chains as well. This first one goes towards the right here. This one comes down. And then this bottom one is going to go towards the left because I'm clicking to the left of the midpoint of this line to give us our direction. And then same thing with this arc. I'm clicking on towards the top of the arc here. so that the direction of that selection there is going clockwise all the way around. It could go clockwise or it could go counterclockwise. As long as they're all going in the correct direction, clockwise or counterclockwise, all the way around like that. And then I click OK. So there's our curved surface. David asked, how do you get to the list of previous live events? If you're not on that page, it is going to be bobcadsupport.com. And then under training, you have live event schedule. That's where you could view this live event today as well. And then the 9th one down is the 3D CAD functions that I went over in a previous one. So this is our 4 edges. I'm going to use the same geometry for skin surface all the way over here. I'm going to skip these other 2 surface functions. Multi-sided patch would be if you have more than 4 edges, and we just select the edges the same way I did for 4 edges. And then the next one is copy face if you wanted to copy a surface and paste it either to offset it or put it into a copy and paste it into a new file. You could do that here. So we'll go to skin surface, and I'm creating the same exact surface with a little bit different workflow in my skin surface function. So skin surface would be the first option you see here is cross-section curves. So I'm going to select the 2 straight lines first. So I'm clicking to the right of this line and then hitting end chain over here. I'm clicking to the right of this bottom line and hitting end chain again. Then I highlight the box for rail curves over here in my data entry window. And then I click on the arcs either towards the top or towards the bottom. In this example, I'm going to click on towards the bottom of the arcs. And then click end chain for this one. And then scroll over to the other arc here and click towards the bottom of this one here. And then click end chain again. And click OK. Now you can see the same result as the 4 edges. It's just a little different workflow. Sometimes when you go into surfacing wireframe like this, sometimes you'll get different results based on your surfacing function. So if you get, a problem with your surface in 4 edges, then you can try to create the surface and skin surface function and maybe get a different result. In this example, I selected the lines first and then the arcs. Sometimes the surface comes out, how do I describe this? The surfaces come out like as in multiple surfaces. If you've got geometry that's sort of segmented together there, if you don't have a straight line like this and a smooth arc like this, maybe you've got a couple of arcs that are, going back and forth different directions. You might have your skin surface function create multiple surfaces for you. And if you've run into that before, you could just change up the workflow. Here, your cross-section curves, the first selection here, instead of the lines that I selected, I could select the arcs first. And then for my rail curves, I could select the lines next. Now in this example, it gives me the same result, but if I have more difficult geometry, it could give me a different result based on how I selected them. All right, so we did skin surface. Offset would be if I wanted to offset this surface out a little bit further. So this distance in 1/8 of an inch is going down. I wonder if I type in a negative number here, would it go the opposite direction? Yes, it does. Cool. So if I type in a negative distance, it'll go above or below, depending on how the surface looks there, and it'll offset the geometry that you've selected. Next is ruled surface. This is another one that is another surfacing function. So ruled surface and swung surface. I don't normally use these, but we'll see how these look here. We'll go to a new file. Already in BobCAD 12 now. That's cool. So we'll go to create 2D. I'll make a few lines here. Let's say like that. Alright, so we got 3 lines up top. I'll make, actually this is going to be the bottom. So these are 3 lines down on the bottom, and I'm going to make 3 lines. Actually, no, this is going to be the top one. I'm going to translate this up. If you guys are following along, I'm sorry. So I made 3 lines like this in a chain. I'm moving it up in Z 1 inch and clicking OK. Then I go to create 2D and go to line, and I'm going to make some lines a little bit further past, let's say a line like this, a line from this endpoint down to here, and then from this endpoint, I'm going to make this one even further out. Okay. So if I want to, this is sort of like cross-section, I guess. You could go to Create 3D and go to Ruled. So first you select the first chain, which will be these 3 lines here. And then I click End Chain over in my Picking Manager. Then I select the other 3 lines here and click End Chain. And there's the surface it comes up with. Sort of a cross section, I guess, but it's not one surface you can see. It's 3 different surfaces that terminate in between the intersections here. You can see this is the example with lines. You can see the example in ruled surface. Maybe if I did a spline, it will do it a little more continuously or a smoother surface there. But that's what the ruled surface is all about. Creates a surface using the selection of 2 wireframe chains with a linear blending between the entities of each chain. And then the next one down is swung surface. It's very similar to this one, but instead of the top and bottom profiles, it's going to be the top profile like this, and then sort of a cross section, I guess you could call it. So if I selected a front view, and I'm going to make a line going down from this here. Now I go to Create 3D and go to Swung Surface. So the first one, trajectory curve on XY plane, so that would be this one, and I click End Chain. And the next one is the profile, and then hit End Chain. Oh, it doesn't like that, does it? Failed in swung surface. Please make sure trajectory path is on XY plane and profile curve is on XZ plane. Oh, so it can't be X, Y, and Z for your profile. Interesting. So let's just do a line on the front UCS. And that is X and Z, I think. Here, I'll just do the line like this. I'll just type in the coordinates here. So X 0, Y 0, Z 1. There we go. Wonder if it has to be connected. Let's find out. We go to Create 3D, go to Swung Surface. I'm going to select the profile first, or the path, I guess you could call it, and then this is the profile, and then click End Chain. And it's still not liking it. I think it wants it to be on, the connected to it. So let's translate these 3 lines. And again, I'm getting a little more advanced into the translate function, which we'll be looking at next, on how I just moved that profile or that path to that profile right at that intersection there. Let's see if I can get this going. So we go to Swung Surface, select the path, End Chain, select the curve, End Chain, follow profile curve, follow trajectory curve. Still not liking it, but you can see the example in the swung surface right here. So you select the path first, and then you select the profile, and you'd be able to create surfaces like that. You can obviously see that I almost never use this. I never use the ruled surfacing or the swung surfacing. My go-to is the skin surfacing function, because you're able to select the top and bottom, and then left and right, and it will create a surface across the wireframe for you. I get the best results with the skin surfacing function. Next would be, let's go and create a cube again. Under create 3D, the last ones here are solid fillet, solid chamfer. So if I wanted to create a fillet on the edge here, I could create a fillet on the edge of a on the edge of a solid chamfer. I could create a fillet on the edge of a solid here, fillet and a chamfer. Surface fillet would be if these are two individual surfaces and they converge, you can create a fillet along the two surfaces. And also, if you have a whole bunch of surfaces and they're all joined together like this and you need to make them into a solid, that would be the stitch surfaces to solid. Now this is already a solid, so let's unstitch it. So I drop this down, and we have unstitched solid to surfaces, the next one down here. Click on the solid and click OK. So now these are all individual surfaces. So I could select the chamfer here, and I could hit delete to delete that out and see inside of it. And maybe I want to make multiple surfaces in here where the chamfer was. But if I've got all of the surfaces here conjoined again, I can go to Stitch Surfaces to Solid, which is the first one down here. Stitch Surfaces to Solid. Select all of my surfaces and click OK. And now I've got a solid again. So when I go to my Evaluate and go to Measure 1, pick Solid, and pick the solid here, it will tell me the area and volume of the solid here. Back to Create 3D, our last one is Unstitched Surface from Solid. So if I wanted to unstitch just one individual surface like the top one here and click OK, now I can select the top one, hit delete, and now everything's stitched together except for the opening there, so I could create another surface to finish up the solid here. Let's see. We'll finish these up and then answer any questions you guys have. Extend surface would be if I wanted to extend the end of the chamfer here a little bit further out. I just click on that edge of the chamfer of the surface there, and then type in the distance in my data entry window to extend out the surface. Split would be if I had a surface in between a solid. So let's say I had a rectangular surface like this here. I could cut this in half by going to Split, selecting the solid. Whoops, this isn't a solid yet. There we go. Okay, so Split, select the solid, and then select the surface to split in half. So when I go to my select mode, delete the surface, and delete the bottom half there. Shell's a cool one. If I click on the bottom surface here, it will create the shell, you could say, or when I type in the wall thickness of 1/8 of an inch, it shells out or hollows out the solid with the wall thickness of 1/8 of an inch there, or whatever wall thickness you type in there. Untrimmed surface, if we had any geometry that, like on the top there, it was deleted or it was trimmed away, you could add it back to itself, returns the surface back to its normal boundary and removes any holes. Break surface, if you had any geometry, let's say we go back to our star here, and I wanted to trim that away from the bottom surface here, I could go to Create 3D, Break Surface, select the surface first, and then select the wireframe, and click OK. And then I can just delete out that surface if I wanted to and look inside from the star shape. And then intersection curve is it will break surfaces where they intersect. Just select the first surface and second surface. It will break the surfaces at that location, and you'd be able to delete the extra geometry there. All right, we've gotten through Create 2D, and we've gotten through Create 3D. David has a question. Can you use solid fillet for an inside corner of a solid? For an inside corner of a solid. I think we saw that here with the shell function itself. But yes, to answer your question, yes. If we had the shell function, so I'm going to go back to doing a cube and then shell on top here. And we've got a corner on the inside of a solid like this. Yes, you can go into solid fillet. You just want to make sure that your radius is small enough to be able to create that radius that you need there. What I normally do is I click on Show Preview down at the bottom of the data entry window so that I can see it in orange and make sure that it looks correct. If it is, let's say, a radius of 5 inches, I don't think it'll create it. So if I click on it here and then go to Show Preview and it just completely wipes out the solid, that means it's going to error out on us. So that's a good way of going to a preview and making sure that it is correct. But yes, to answer your question, you are able to do a solid fillet on the inside corner here of a solid like this. Good question. Let me know if you guys have any other questions in Create 2D or Create 3D. We'll get into our utilities and we'll be finishing up from there because Evaluate, there's not a whole lot in there, but we'll take a look at that too. So utilities, I'll go to a new file. We have our translate, rotate, mirror, scale, all of the move functions in here. So I'm going to go to my trusty rectangle there, 2x2. First, I'm going to go to utilities and go to translate. I'm going to select my rectangle. Now I can type in a translate amount in an incremental distance under translate amount. I'm going to move it over 1 inch and move it up 1 inch in Y. And then click OK to finalize that. Then I'm going to select it again. And you can see I can click on the center of the preview here. And then I can drag the preview over and then click on it a second time to place it wherever I want it to go to. And then click OK to finalize that translation. Then let's say I want to move it to an exact location. I don't know how far out it is, but let's say I want to move this corner, the bottom left corner of the rectangle, back to my origin location. I'm going to select the geometry again first. I'm going to pick a start point. So you can see down below translate amount, there's start point and there's geometry center. I'm going to change that to pick. And then I'm going to pick a point. I'm going to pick this endpoint of the line. And then I can move that to a certain endpoint that's highlighted here. I'm just going to type in under the endpoint selection, I'm going to type in x0, y0. And it's going to move that down to the x0, y0 location. If I want to move it to a certain point that I don't know the position, let's say I want to move it to this point out here in space, I'm going to go to Utilities, go to Translate, select my drawing. I'm going to pick a start point, which is that corner right there. And then I'm going to pick an end point, which is going to be this point right here. And then click OK, and it'll move to that exact location. So that's our translate function. Then we go to rotate. First off, before I get into rotate, with translate, with the BobCAD users that are familiar with the older versions of BobCAD, you had your delta and you had your sketch enter. Now you don't have to change between delta and sketch enter. Your delta is your translate amount up at the top, and your sketch enter is your start point and end point selections. All right, so we go to rotate. I'm going to select the drawing here, and I can rotate it around in the z-axis because we're on an x and y plane. So I'm going to rotate it around 45 degrees, and you can see it rotate around 45 like this. It rotates the geometry center by default. So if I want to change that here in my rotation center in rotate, I can change to pick, and I'm going to move it to x0, y0. So now you can see when it rotates from the origin location, rotates 45 degrees, and then I can make multiple copies going around. Let's do 2 copies to, rotate it around and make 2 additional copies there. All right, so we had our rotate function. We have our mirror function, so it'll mirror across the y-axis, mirror across the x-axis, or mirror across the z-axis, which is nothing because we're at z0. Next is scale. So if I wanted to scale this drawing up, I could scale it up with my scale factor in my data entry window here of 2. It's going to double the size. If I want to make it half, the scale factor would be 0.5 here. Next would be align. Align's a really cool one. Let's say I wanted this corner to be at the XY location. So now I don't have to translate it back over. I don't have to measure this line to see what the angle is that I got to rotate it around to get it back to my origin location. I can just make a new origin location under align. I zoom into my square here. I click on my new origin location that I want, which will be this bottom corner here. My new X direction will be this point. I'm going to click on this midpoint of the line here. And my new Y-axis direction will be the midpoint of this line going in this direction. And then I click OK. And it'll translate and rotate everything around for me automatically. So that will be my new origin location. Then we get into the trimming and breaking functions. These are really useful. Let's say I've got 2 squares out here and they're intersecting geometry. Let's say I just want to remove everything on the inside. I go to Utilities, I go to Quick Trim, and I trim away all of these inside lines here. It trims up to the next intersection from that line that I clicked on. Now I'm clicking to the left of this line here. If I click to the right of this line, it trims away what I click on. A little bit different than the trim 1 entity and trim 2 entity. Now the trim 1 entity, if I click on this top line right here, I'm clicking to the left of the intersection here. So when I click on the next line, it's going to keep what I clicked on and trim away whatever was past that intersection of that line. Same thing with my trim 2 entities. If I click to the left of this line and I click to the top of this line, it's going to keep what I clicked on and trim away everything past it. Same thing with this one. I'm going to click up towards the bottom of this vertical line and click to the right of this horizontal line. It'll trim away the excess there. Same kind of thing with, so that was our break functions. I'm sorry, those were our trim functions. We'll get into break. We have these other 3 that I don't normally use, but trim screen I use sometimes. Trim screen, I could click on a line and then click a second time where my cursor is. It's going to trim that line up to where I clicked on the second time. Trim modal, trim strings, I don't ever really use, but if you window select things and select a whole bunch of entities, it will trim everything that's excess there. Then we get into our break functions. Let's say I didn't want to trim that halfway point. I wanted to break it at that halfway point. So we have break screen. So I could click on this vertical line here and then click on the midpoint. And so now I've got 2 equally distanced lines there, broken at that midpoint. We have break divide. So if I wanted more than 2, let's say I wanted 4 breaks, or 4 number of divisions, so this line would be 4 equally distanced lines here. Break many and break entity. So break entity would be if I wanted to break this horizontal line where it intersects with this vertical line, but I don't want to trim away that geometry. I want to keep it for, more 3D modeling for that. It will be 2 lines that are just broken at that location. I could also go to break many and just window select all of this, and it will break all of these lines at every intersection for me automatically there. And then break angle would be for arcs. So if I've got a circle out here and I go to break angle, 180, well, let's start with 0. 0 is my 3 o'clock position. I think our developers really like trigonometry because 0 for an angle is always at the 3 o'clock position here and goes counterclockwise. So if we type in 90 degrees, it's going to go counterclockwise to the 12 o'clock position here. If I go to 180, the 9 o'clock position, and I could go to 270, and that'll be the 6 o'clock position. You could also say negative 90 if you wanted to, or you could also say 360, and it will be at the 0 degree location there, at the 3 o'clock position. You could go even further past 360 if you wanted to, I guess. All right, so that's everything in the break function, everything in the trim function. Let me know if you guys have any questions with those. The other ones are smaller ones that I don't normally use, but we'll take a look at them. We go to stretch, so we could stretch a line out. Oops, let's go with the top one here. So if I wanted to, man, these are all broken at, there we go. So let's say I wanted to stretch this line out further. So sort of like an offset option from this vertical line, I could stretch it further in the x-axis, or I could move it further back in the x-axis, different options like that. Sort of like an offset option. That's why I don't normally use that, because I normally use offset. Drag corner and deform. So drag corner would be if I click on a line, or I'm sorry, if I click on a corner like this, I can drag the corner out to a certain position. And deform would be if I click on a line or an arc, I can change the curvature of the line or the arc there to make it an arc. Those 2 functions are the best functions for Bob art. So if you guys are vectorizing, tracing an image into a drawing, the drag corner and the deform to be able to modify your drawing after it's vectorized a little bit, that's perfect. Equalize would be if I had multiple lines like this and they were different distances, it will create them into the same length. Next we go to clean up optimize. So if I have all of these lines that are broken up and they could be created as one line again, it will clean up the drawing and make it into one line again. Next one over is explode. Explode converts geometry entities into only lines and arcs. So if you had splines, or if you had text, or if you had hole patterns or point patterns, things like that, it will break it up into single entities. Especially with splines. Splines, it'll break it up into lines and arcs, and then you'll be able to modify the spline a little bit more easily. Erase doubles. Let's say I accidentally created a line on top of each other. It will tell me any corrections that have been made. Make arcs tangential. So sort of like the cleanup option. If there were multiple arcs in this circle and they could be cleaned up, you have that option there. And then the last ones, add property, edit property would be if you wanted to add notes in the drawing. And then reverse contour would be for the contours of the direction that you wanted to create. And reverse surface normal. Now I'll get into reverse surface normal before we get into our evaluate, and then we're pretty much finished. So get in your questions if you guys have any questions there, and I can answer them. Now this one's a little bit I don't know, you could say a little bit obscure there, but it's really useful when we get into 3D modeling. So when we try to add solids together, we try to do an extrude boss to add to a solid, extrude cut to subtract from a solid, subtract holes with our extrude cut and things like that. Sometimes the 3D model, the function will fail on us. And the biggest reason is because of surface normals. So with this cube to look at as an example, you can see that there is, when I go to reverse surface normal, it will show a red dot and a line going out from the surface for each of my surfaces. Let's say I click on the top surface and click OK. Now I've only got a red dot. What happened to the line? Well, now it's inside of my solid. And I hid the surfaces of the solid by just hitting S on my keyboard, S for solid, to hide or show the solid there. So my surface normal, we sort of colloquially call this a tail, right? So there's a red dot and then the tail pointing inside of the solid. We want these tails to be pointed outside of our solid. So that way we can tell the software each of these surfaces the direction of the outside of the surface for our solid. So sometimes you could have a solid inside of a solid maybe, and then you can tell the software, okay, this is the inside of the this surface is on the inside of the solid versus the outside, and things like that. But yes, so when you go into 3D modeling and you run into issues, that's a big one to go to, your reverse surface normals. I know this is usually a new topic for customers, but it can be really useful when you get into more complex 3D modeling to make sure that for CAD, because then when you get into, cutting out holes on this surface and the surface normal is on the inside, you want to make sure that it's on the outside so that we can make holes on top of this surface for our solid. And also could be useful for CAM. When we get into milling, we want to make sure that this is the outside of the surface so that we're offsetting when we're doing 3D machining, 3-axis machining, surfacing on this surface, we can make sure that it's on top of the surface rather than offsetting on the bottom of the surface. So then, what's next? That's it for the utilities. Let me know if you guys have any questions with Create 2D, Create 3D, or with utilities. We'll go to our last tab that we're getting into today in CAD, which will be Evaluate. So I'm going to make really basic shape here. Let's go with this one, so that we've got some angled lines to look at as well. So we go to Evaluate. I normally just go to Auto Dimensioning. That's a new function that we have in our newer versions, separate from the dimension functions in the older versions here, where you can, in the older versions, you had to make sure, okay, I'm getting my horizontal distance. Okay, now I'm making sure I'm getting my vertical dimension here of this line. Okay, next I want to make sure I get the total distance, so that's other distance here. Now in BobCAD, you don't have to do that. You can you have auto dimensioning now. So here in auto, I click on auto, I click on the line, and then I move my cursor up high enough to get the horizontal distance. I move my cursor far enough to the left to get my vertical distance here. And then I move my cursor close enough to the line to get my total distance of the line. So that can be really useful, because then you could just click on a point, for example, to get your X, Y, and Z dimensions. And angle would be if I click on both of these lines here, it'll give me the angle between the two there. So everything can be done in the auto dimensioning now. You don't have to go into all these little dimension options anymore. And if you have something that you need to type in that we don't have a dimension for, you can go to the note function. Type in your text, click on a point to create a leader line with the note you wanted to add in the drawing here as well. And we'll finish up with creating a print here. So I'm going to go to File, And we're going to go to that merge function again there as well to merge one of our template files that we have already preloaded in the software program merged into the drawing that I have open currently. So I'm going to go to this PC. I'm going to go to my C drive. And now this is sort of hidden in the background of your software program, but you can always copy and paste this folder onto your desktop or into your downloads or something like that. So again, it's under this PC. It's under your C drive. It's under BobCAD-CAM data. It's under BobCAD-CAM v37 or whatever version you're working in. And then in the folder examples, and then in the folder title blocks. So again, this title blocks folder is hidden pretty deep in your computer. You can simply right-click on the title blocks folder right here, and you can copy and paste it onto your desktop or wherever you want to place it if you're using these title blocks very frequently. So these are title blocks files that are all preloaded in the software program. I like using this 18 by 24 landscape, so it's looks like basic print there. I can zoom in and I can type in my revision number, my sheet number, type in the company name and things like that, and I could save it as another template there. And then you can go to File, you could go to Print, and you could print it to a printer. You could make sure that it's landscape versus portrait, and then you could also print it as a PDF as well. And I think that is the end of our webinar today. We went through all of the tabs for the CAD functionality. We went through Create 2D, we went through the Create 3 we went through the Create 2D functions, we went through the Create 3D functions, we went through all of our utilities, and our Evaluate tab here as well. You know, if you don't want the dimensions here on your print, you want to measure something, and then you don't want it here in your drawing, you can go to here to measure 1 and measure 2. So measure 1, you can click on a line and get the total distance of it, start point and end point. And measure 2 is if you've got a point somewhere out in this corner maybe, and you want to measure that to this corner over here, it'll give you total distance, distance in X, distance in Y, distance in Z, and total distance there. All right, perfect. And we're leaving off with this print. I'm going to sit back for a couple minutes. If you guys have any questions with what we've gone over with our CAD functions in here, again, if you want to see how these CAD functions can be used for a 3D model, sketching on different planes, and also I measured the 3D model after the fact so that you can work through it with me and make sure that you've got the same result as me. That is on BobCADSupport.com. Under the training tab, you have training events. So I'll even pull that up while I'm waiting to see if you guys have any questions. So here under BobCADSupport.com. Good, thank you, Craig. I'm glad you stuck around for the whole webinar and learned something today. And let me know if you guys have any questions or if you learned anything today. What did you guys learn? How did I help you out? Just to make sure, see what you guys are learning in the software program and what we could go over in the next webinar and things like that. So we go here to BobCADSupport.com under training. At the top here we have virtual training schedule. And so the top one is CAD Fundamentals that we're in right now. We're going to scroll down to number 9, which is Learn the Fundamentals CAD Programming, the date of February 5th. So you can see this 3D model that's loading up here. There you can see I sketched on different planes and made a 3D model, went through maybe an hour or hour and a half to go through that functionality there. And it's a really good video, I think, to learn the basics of 3D modeling, sketching on different planes, and getting in more of the 3D dimensional realm, rather than what we did today was more of X and Y sketching. But yeah, if you guys have any questions, please let me know in the comment section, and I'll sit back for another minute or two to see if you guys have any questions. But Thank you again for viewing the live event today. It is every other Wednesday. So it was today, May 28th. The next one is going to be June 11th. And the topic is still to be determined because we send out a survey to ask you what you would like to see in the next live event. And that way we know that we are going through lessons that you guys would like to see. All right, I don't see any other questions you guys have, so I'm going to finish up today. Thank you guys again for viewing the live event today, and we hope to see you in the next live event June 11th. Thank you very much. See ya.